This episode of the HVAC School podcast is made possible by our great sponsors and partners, which are Mitsubishi Comfort and Carrier. The Mitsubishi Comfort and Carrier are the two who have really stepped up to make the HVAC School podcast and website possible. A lot of people ask me, hey Brian, how do you write all this stuff? How do you have the time to make all these podcasts? Well, the answer is that it's because of Mitsubishi and Carrier, doggone it. I also want to mention a new company that I've been working with. You may have listened to the podcast previously from AirOasis, and AirOasis is a great company. I don't know, when you think about indoor air quality products, it's very controversial. Everybody has their product that they like, products that they don't like. Let me tell you what I like about AirOasis. It's made in the U.S., and they're really good people. Like the actual owners, I've talked to them. They've got great research that's been done by Texas A&M University on the products that they sell, and they're just honorable human beings. You just know when you talk to somebody that they're not out selling snake oil because they're just down to earth. These are good people. John Bennett is a really good guy. I've had a chance to talk to him a few times, and they make great bipolar ionizers. They make a great APCO technology, which is a PCO-based technology, and I like both of them. We're using them in our company, Kalos. We've done some testing on these products using Petri dishes before and after. We've been impressed by what we've seen so far. We've got some more testing going on right now, and I'll let you know the results of those. But I'm going to encourage you to just take a peek at their website. So if you go to airoasis.com, airoasis.com/reseller. That's where you can go on and just sign up, send them your information, and then they'll contact you and talk to you about places locally you can buy the products in order to start offering them in your business. They can answer any questions that you may have. If you have any questions about the studies that they've done, you can find that all at airoasis.com. And what you're going to be struck by right away when you talk to AirOasis or when you go on their website is that it just doesn't have the level of hype that you may have seen around indoor air quality products. They base it more around the science, and I really appreciate that.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
Seriously, his initials are B.O. for a reason. Brian Orr.
Heidi-ho there, neighbor. It's true that my smells aren't always the best. And what's strange is that when I was in the field more often, it wasn't as bad. I don't know what it is, but whenever I have to speak in front of people, and I don't think I actually enjoy speaking in front of people. It's maybe it's just my ego there, but I like it. But for whatever reason, whenever I do, I sweat like a pig. And I guess it turns out pigs don't sweat, but that's another topic for another day. And I smell really bad. That's the point. And so, yes, my initials are BO. And yes, it is appropriate if you ever see me speaking somewhere or you meet me at a conference or something, you're probably going to notice that. And I apologize in advance. But that's not what we're talking about today. This is the HVAC School podcast, the podcast that helps you remember some things that you forgot along the way as a technician, or maybe helps you remember some things you forgot to know in the first place. For techs, by techs. Today's episode is part 2 of a conversation that I had with Trevor Matthews from Emerson. So big thanks to Trevor, big thanks to Emerson for coming on and talking about why compressors are murdered and what happens, what causes their murder, the different causes. And we already got done with flooded starts and flood back, and now we're going to talk about slugging. And so here we go. Trevor Matthews from Emerson talking about compressor murder. So we got flood back, we got flooded starts. What else?
So next would be slugging. We talked about that a little bit earlier. Slugging really happens when you're trying to compress either liquid refrigerant or oil in your compressor. And a few things that you will see on a semi-hermetic compressor, what I tell the guys to do is if the compressor is not running and it's down and you need to inspect it, before deeming it a failed compressor, pull off a head. It doesn't take a lot of time to do that. Pull off the 9 or 12 bolts, I think it is, on the head, and then look at the valve plate. See if there's any damage on the valve plate. See if the suction reeds are broke or the discus is busted. And really look at the pistons to see if there's any damage, as well as broken rods. Inside of the scroll, those ones are a little tougher, or hermetic compressors, because you can't really see inside them. You do have to cut those ones open to see what really happened. It does take a little bit of time, but the more and more you investigate on what's happening inside the compressor, you'll figure out what caused that failure. Some of the other things from the slugging on a reciprocating semi-compressor that I didn't know about as a mechanic in the field, but wrist pin lubrication. It's something that's not really talked about even in schools very much, even through the school I went, until I came to Emerson to find out the wrist pin lubrication and wrist pin wear. And so what I mean by that is if your compressor took a slug and it damaged one of the discharge valves, and the slug would take one out. What happens then is that you have discharge gas pushing back down onto that piston. It's not really letting that lubrication access the wrist pin. And while it's pumping and pumping and pumping, you start to get wear on the wrist pin, which is connecting your piston and your rod together. And as it runs and runs and runs, it continues to wear and wear. So a mechanic will come in and he'll pull off the head and say, oh, I have valve damage. Compressor seems good, so I just need a new valve plate. A check that every mechanic should do if they have a damaged valve plate, discharge valve, is they need to take off the oil pump. They need to put the piston top dead center of it and push down on it. If that piston drops a little bit, that means you got wrist pin wear. So the mechanic could now replace this valve plate and start it up, but all of a sudden he hears knock, 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 knock. My great impression of a knocking compressor. But that valve plate is not going to fix the wrist pin wear. So that's something that I learned over the past few years here at Emerson, that if you do have a damaged or broken discharge valve, do that check on a semi.
So we have a lot of different types of technicians. We have some who are listening to you right now and they're like, oh yeah, absolutely, wrist pin wear, I'm with you. And we have some who are like, what in the HE double hockey sticks is that guy talking about? So if you imagine a piston, okay, so take your fist and hold it in the air, and you imagine your fist is the piston and your wrist is where it connects to the rod. And so the rod is your forearm and your wrist is actually where it connects. And what he's saying is if you imagine this thing pumping against a broken discharge valve, every time it pulls back down, it re-expands discharge gas in behind, and eventually that washes out all of the lubrication as well as causes it to run hot as well. But over time that you get slop in that wrist pin, and so you replace the new valve. It looks okay because you're looking at the top of the piston when you take the head off, and you think, oh, okay, well, that's just normal. But that slop in that wrist pin results in that thing still hitting because it's able to slop up and down and causes additional damage, and also isn't going to work correctly. It's going to knock, like Trevor did that, such a lovely rendition of how it sounds when it goes knock. I think that's actually the lowest RPM compressor I've ever heard. Yeah, it's like running at 2 RPM, knock, knock. Anyway, that's a really great point, though. And the more you understand how a compressor works, actually functions inside, the more this stuff is going to make sense. And so if you haven't had a chance to go through a rebuild class or a class with Copeland, I would definitely suggest that you look on Emerson's website and sign up for some of those, because it really helps you understand how these things function.
For a scroll now, you really have to cut it open to see it, because with a major slug in a scroll, you could break a flank. And what I mean by a flank, if you ever looked inside of a scroll, as that scroll set goes around in a circle all the way to the discharge point, we call those walls flanks. And when you're trying to compress oil or liquid, we do have some safety device where we have axial compliance and radial compliance, which means we'll separate the scroll sets to try to protect it. But if you have a major slug, you can potentially crack the flanks or the Oldham coupling. And what the Oldham coupling is, it actually does the rotation for it, give it the orbiting motion in it. But you can do a lot of damage with a flooded start, which is really a slug in a scroll. We haven't really talked too much about hermetic compressors, reciprocating hermetic compressors, but there's a lot of things that could happen with those as well. And I seen one, actually the first 6 months I was working at Emerson, I was working with one of the experts here, Bruce Bosnell, doing an inspection. And he said, Trevor, grab that compressor and check the oil. I think it might have been a CR compressor possibly. So what I did is, I'm like, Bruce, why would I check the oil of the compressor? He was like, Trevor, well, there's no sight glass on it. I'm like, oh, okay. So he gave me a measuring cup, and I actually filled the measuring cup up. I had 32 ounces. I filled it up again, 32 ounces. And then he was like, Trevor, now check the oil information on the label. I'm like, oil information on the label? He's like, yeah, it'll tell you what the charge of oil should be in there. And I looked at the charge of oil, and it was only like 34, I believe it was. So I had nearly double the amount of oil in that compressor. And so when we took it back, we had a smashed reed and a valve plate, a damaged valve plate. And he was like, Trevor, this occurs a lot of the time when a mechanic will go out and replace a compressor. They'll pull out the compressor, put a new one in. 6 months later, could be another service contractor on it or another mechanic on the job and have another failed compressor. Really what's happening is that oil is logging into the system. It'll come back all in one shot and damage the compressor really bad. So I really stress on any compressor without a sight glass, you really want to measure that oil. It's very important because if you do not have any oil in that compressor that comes out, where is that oil? Potentially still in the system. If you didn't have a leak, it will be still in the system.
That's very interesting. I'm going to confess that I've never measured the oil coming out of an old compressor before, but makes sense because that oil can't go anywhere. It's not like you may have a little bit that leaked out if the system had a leak or something, but it's not, the majority of it's still in there somewhere. So yeah, it's an interesting point. Makes sense.
And one last thing about slugging as well is that lots of people have mentioned to me that, well, I have an accumulator that's going to protect against slugging or flooded starts in the system. But at the end of the day, it doesn't. It does help protect against flood back. But if your system's off and your accumulator is full of liquid, there's a potential it can migrate back into the compressor, right? So I just want to point that out, that just because you have an accumulator, you still can have off-cycle migration.
And this is, I think, where techs get confused. It's not like liquid migrates to your compressor as a liquid. It migrates to your compressor as a vapor, and then it condenses into a liquid inside the compressor. So it's not, and let alone the fact that you've got vapor pressure, there's actually traction of refrigerant to the oil itself in the compressor, let alone the temperature differential. So there's a lot of different reasons why you end up with liquid refrigerant in your compressor. And an accumulator, while it certainly will help, even with flooded starts, it's not a savior. A good solid operating crankcase heater is probably the simplest way to deal with that. And then, like you mentioned, pump down solenoid is also a good practice.
Yeah, exactly.
Cool. So what's next on your list?
Overheating. This one here, I've seen it so many times in the field as a mechanic as well as here at Emerson. And this is something that is overlooked by a lot of mechanics out there, I believe, and I see as compressors come back to us. So overheating was one of the major causes of compressor failures for us in the past. We do have a lot of new protection devices like CoreSense, Performance Alert to help protect against these failures. But some of the main causes of overheat is like high compression ratios. And I stress this onto a lot of the apprentices, and I ask them, do you understand what high compression ratio is and how to calculate the compression ratio to a compressor? Because that is very important to know when checking compressor. To be honest with you, Brian, as an apprentice and a young mechanic, I did not check the compression ratio. If the compressor wasn't running and I got it started back up, it wasn't really on my mind. But as I became a journeyman and more experienced, it's something really to look at, because if you have low suction pressure or high discharge pressure, you are doing more work on that compressor. You are causing more heat to that compressor. You'll be getting less cooling to the motor, and you might need to look around at the system because there could be some sort of system related issue causing that. Potentially a dirty condenser. You could potentially need external cooling like a head cooling fan, demand cooling, things like that, depending on the system. One of the main causes for overheat is really when your system gets too hot or your compressor gets too hot and the oil starts to break down. And that's one of the big things. You don't have the ability to lubricate when your compressor gets too hot. And really, this overheat can cause that oil to break down chemically, and then it can cause harmful carbon and acids in that compressor.
Yeah, you mentioned a couple good things there. Like when a compressor gets too hot, there's a couple things that I want to mention. When anything ever gets too hot, what happens? Well, things, when they get hot, they expand, right? And when they get cold, they contract. We understand that. This is like a universal rule here. And so when you have things getting hotter than they're designed to get, that means they're expanding more than they're designed to expand. And when you have this range of temperatures, especially this fluctuation, we know that we understand with metals, when you do that, they become brittle, they break easier. And so that's one factor just alone. And when you get things too hot, we know that that's not good. And it's fairly obvious. But the next thing that you mentioned is critical, is that once you overheat oil, then it loses its lubricating properties. It can actually completely break down, let alone it also affects its viscosity. The hotter you get something, the thinner the oil gets. The colder it is, the thicker it gets. And these things are engineered to function within a particular range. And when you operate something outside of its range, it doesn't work properly. I think one thing that people miss a lot of technicians miss, and you mentioned this in the case of compression ratio. There's a podcast with Carter Stanfield that if you want to know more about compression ratio, go back and listen to that because Carter has some great insights there. But one thing that's a really important factor is load on the system makes a huge difference as it relates to how much refrigerant is actually moving through the system. When you have a low suction pressure, you also have a low refrigerant density. When you have a low refrigerant density, you have a situation where you don't have as many refrigerant molecules running through that compressor, which results in high compression ratios, more work, but also ineffective cooling because you don't have as many refrigerant molecules running through that compressor. And so there's just a lot of things that impact the temperature of a compressor that have such a big impact on its life expectancy, how long it's going to live.
Yes, exactly.
What else did I miss there?
Some of the things that I'd like to say for guys to check is really check the temperature, right? Check your discharge line temperature. This is a big one that I talk to a lot of mechanics across the country, and I ask them, how often do you check your discharge line temperature, right? It's a quick and easy measurement. 6 inches from the discharge service valve, check the temperature right there with your temperature probe. There's a few different numbers that Copeland use, but the main number that I use is 225 Fahrenheit. If you're above 225 Fahrenheit, you're going to start to break down that oil because inside either the head of the compressor or the head of the scroll, it's a lot hotter. It could be 50 to 75 degrees hotter in that head. And that's when really you start to break down, the oil starts to break down, right? So do the discharge temperature check on the discharge line. Very important.
Yeah, and if you see something that's too high, well then, you should be doing your compression ratio anyway, but look carefully at your compression ratio. Look carefully at your suction temperature. Look carefully at obvious things like, is my condenser coil clean? Those are fairly obvious things, but whenever you have higher head pressure than you need, head pressure being driven up too high, or suction pressure being too low, or superheat too high, those all impact your temperature of your head. And this is a subject that I think gets missed a lot as we became more fixated on superheat. And we started thinking about no flood back at all costs. Sometimes we end up with systems where we maybe set a TX valve properly inside, but we didn't think about what the temperature of the suction gas coming into the compressor was. And if you have a compressor that's running 15 degrees warmer than it should over its life, I can pretty much assure you that compressor is not going to last as long as the one that was dialed in perfectly. Be thoughtful when you check that, and absolutely checking discharge temperature is a really nice test to do, and you get a lot of information about how that system's working and the longevity of that compressor by testing it.
Yeah, exactly. So some of the main checks that I always stress to talk about, you mentioned most of them already, is set your minimum superheat, properly set your low pressure control, prevent loss of charge, do not let that suction pressure go below your compressor design, maintain that compression ratio design, like you said, and have a correct or adequate refrigerant charge in that system.
Yeah, one point to make, because we talked about preventing flooded starts by using a pump down solenoid, that even makes it more critical that your low pressure switches are high quality and set in properly. Because I've seen systems kill themselves by pumping down, and now that compressor pumps itself down into a vacuum and attempts to run, which that's a big no-no. You do not want compressors running with no refrigerant running over them because they're going to overheat in a hurry.
Exactly, Brian. There's one other point I want to put out there for overheating and some of its causes. Most of my background in the field was as a supermarket mechanic service and installation, and I've worked on, installed tons of semi-hermetics. But this is one thing that I've really only learned here when I'm working with the experts. Something called blow-by. What blow-by is that when you get high discharge temperatures and you start breaking down that oil, you have the lack of lubrication on those cylinder walls. So you start to get wear on the cylinder walls of a semi-hermetic. We'll use a 3D, for example, 3D Copeland compressor. So as those cylinders and the pistons are pumping up down, it's wearing the piston and cylinder wall. What blow-by is as that piston is starting to compress the gas goes around the piston. It doesn't all go out the discharge port or up the reed. It is pushed back into the compressor. Inside Copeland Semi, you have two locations. You have the body separated from the crank. So that means the motor is separated from the compressor inside. In between those, you have an oil check valve. This oil check valve is used for two purposes. So on startup, it closes so it doesn't blow all the oil into the motor compartment. And the second is to help feed oil after the compressor starts to run. So it'll open up. You'll always have a little higher pressure in the motor and stator compartment than in the crank side. So as the compressor starts to run, the suction pressure starts to build a bit, and then that oil drains into your crank side, and then the oil's pumped through. But with this blow-by happening, and as its compressor is pumping, it pushes pressure down into the crank side and shuts that oil check valve. So really what happens now is that a service mechanic will give a call at 2 o'clock in the morning, and he'll go up to a rack, we'll say, and all of a sudden the compressor's off on its centronic or in its oil protector. And he'll look in the sight glass and he'll like, oh, it's half full. This must be a nuisance call. Press the centronic and okay, go get my paperwork signed off. But in theory, there was a major issue with that compressor. And to be honest with you, I potentially overlooked a few of these examples in the field because I didn't know. Really bad blow-by, you will see actually when the compressor starts up, and you can watch the oil sight glass and you will see it drop. Because that oil feed check valve is closed, you can't feed all the main bearings. So that is one point that I want to put out there that I didn't know as a mechanic in the field. Blow-by could be a major issue.
Yeah, a pretty serious issue and a hard one to diagnose, which is the challenge in some of these. It's like it's going on inside the compressor and you don't want to have to tear it down every time to find these problems. But just being aware of what can occur, I think will help you maybe think about it twice. And so that's a perfect example. If you think, oh, shoot, this is just a nuisance problem, right? I'm just going to reset it. Maybe think twice about it and see if this might be what's causing it, if blow-by might be impacting the system.
Yes.
All right, so what else do we have on the list?
So the next one is loss of oil. This is another tricky one. Oil, for me as a mechanic in the field, electrical and oil issues were really the toughest to find, especially if you didn't have a sight glass on the compressor. If you did have a leak and you came and did a repair, fixed the leak, and there is oil all over the place, do I add oil or do I not add oil? And that's a tough one. You want to make sure that every system has enough oil in it. When you do have a sight glass, that one's easy to tell. If your system is running, it has a half sight glass, you shut it off, it still has a half sight glass, perfect. You have the proper amount of oil. At the end of the day, you want to make sure the oil leaving the compressor equals the oil returning to the compressor, right? And if you don't have that, you're going to run into major lubrication problems, potentially seize the compressor or electrical failure due to lubrication. Some of the things you want to look for is, I already talked about, improper oil charge. If the compressor is short cycling a lot, this could cause oil issues because every time that compressor starts, it shoots out a little bit of oil with the gas. Starts, shoots out a little bit more oil. If this happens a lot of the time and continuously happens with short cycling, you could actually shoot too much oil out of a compressor. Doesn't give it enough runtime to pull that oil back. And then if the oil can't reach the bearings, you're going to run into bearing issues as well as overheating issues.
Can oil issues also occur? And I'm going to confess here, this is something that I don't know a lot about. I mean, I understand, obviously, when you have lower suction pressures, you have lower refrigerant velocities. And then also, obviously, tubing size is also a factor with refrigerant velocities. But can you run into issues with oil loss in a compressor? Because it's, of course, a small amount of oil loss if you don't have an oil separator is common. You're going to be constantly recycling oil through the system. But do you see it get stuck in an evaporator, say, when you have lower than designed refrigerant velocities? Is that a real problem that exists out there?
Yeah, that definitely can be a problem. It's very important that in the installation, you work with the manufacturer of the equipment and follow the specs. These manufacturers that are building different types of equipment, and it doesn't matter if it's from air conditioning to refrigeration, they will write a lot of times and give you the distances, the size of the piping to it. If you don't follow that and you don't have the proper velocities, like you said, you could run into oil issues. Like if you don't have the proper piping, I've seen it before as a mechanic in the field where I was working with a journeyman mechanic and he actually was drilling holes into an evaporator. I'm like, what are you doing? And then all of a sudden, a couple of gallons of oil was coming out of the evaporator. What has happened was instead of piping it all the way back to the compressor, they sloped the lines to the evaporator, which is a huge no-no. So proper piping practice is very important, as well as traps. I've seen it out there where there was no traps on certain systems with high rises. in the pipe and running into oil issues back at the compressor. So they want to make sure proper piping practice is taken into account.
All right, so let's move on now into contamination. So what are some contamination problems that can occur?
The main contamination issue that we see is moisture. A lot of the times when a compressor comes back and we pull it apart and we get something called copper plating, we know that there was a lot of moisture or heat in that system. And that is really from the POE oil being broke down. POE oil is very hygroscopic, so if I really stress that mechanics out there need to use the proper tools. Use a proper micron gauge, use a proper vac pump, and test these tools. And I know you stress on it a lot in a lot of different podcasts at you, but if you do not change a filter dryer every time you open a system, you can lead into these contamination issues. If your system is running high heat with POE, like I said, it will break down that oil. High moisture levels will break down that oil and form acid and sludge, which will potentially cause a motor failure. Another one practice that you said is make sure when you're reaming pipe or cleaning pipe that you try your best not to be dropping that into the system, because that can lead into a lot of different problems within your system. A few things that you can do, especially on a semi-hermetic, if you pull off a head and you see copper plating and it actually just looked like copper on the head, what has really happened is that moisture in the oil has caused acid. It is pulling and scrubbing the copper and it brings it back to the compressor, and you can see that copper plating has occurred from that.
Yeah, the inside parts of a compressor aren't made of copper, so if they look like copper, that's an indication that something's wrong.
100%.
So contamination from acid, mostly caused by moisture, also can be caused by overheating, breaking down the oil, sludge, copper shavings, things like that, anything, and you're not supposed to get anything inside the copper. In my early days, the first company I worked for, there were some installers who would run copper lines without sealing off the ends through underground chases, and they would be full of sand and dirt, and the tape would break. They would just tape the ends, the tape would break, and it would be full of sand. I'm sure that's another thing that Emerson doesn't like is when you have copper lines full of sand. That probably also is not.
Yeah.
It would be considered a contaminant.
Yeah, and definitely. There's a few things guys can check too. We have a document called 93-11, Lubricants and Refrigerants. It's a good document for mechanics out there to understand what oils and what refrigerant can be put into the Copeland compressors. I get calls a lot from different people. Can I put this additive in your compressors? Can I put this additive in? And really in that documentation, it is going to tell you what you can and cannot add to a Copeland compressor. So that's a good thing to check. The main thing is if you're servicing any system and the guys really want to change the filter dryers every time to make sure that you're pulling out as much moisture out of that, as well as using the proper tools, like we mentioned, vac pump, micron gauge, get it to the proper testing.
Yeah, I've heard guys talk a lot about, I'm pulling all the junk out of my system with the vacuum pump. It's like, no, vacuum pump doesn't pull junk out of the system. It's not going to catch copper shavings. It's not going to catch carbon that's in the lines that got scrubbed with the POE. I think one thing that's also interesting to mention is when you do retrofits where you went from mineral oil and now you're with POE oil, you can have lines that had carbon buildup for years and years when they didn't flow nitrogen when they initially installed that piece of equipment, that when you put in that POE oil, it actually starts to scrub all those lines and you get all kinds of stuff out of the system that you didn't have before. So when you're working with POE oil, and this is true of even in the past, but nowadays especially, you really need to be replacing your line dryers all the time, anytime you open that system, because it's going to pick up all kinds of stuff and you don't want it going into your expansion valve. You don't want it going into your compressor. Much better to catch it in a good quality line dryer.
Exactly.
Anything else to wrap up with?
There's lots more stuff. Compressors, to me, they are still evolving. There's so much that can happen and can go wrong with them. It's really just do some proper compressor and system troubleshooting checks. And if you follow these, like I said earlier, if you have a proper checklist and use that all the time, you will become better at troubleshooting compressors. So I'm going to go through a few of compressors and system troubleshooting check that guys should follow. Some of the preliminary troubleshooting checks, they should understand the application that they're working in, right? Is it a high? Is it low? Is it medium temp system? What are the design temperatures that should be running? What is the required subcooling and superheat? What type of refrigerants and oils are used in that compressor or that system? Understand the sequence of operation. You see this a lot in HVAC or in furnaces, central air furnaces in Canada. There's a sequence of operation. It's no different from a package unit or a refrigeration system. Understand that sequence of operation and then figure out, is it a problem mechanically or electrically? That's really, at the end of the day, if you know, most of the compressors that come back to Emerson, they're electrical failures. Most of them were caused by a mechanical failure, right? So that's some of the preliminary troubleshooting. For the electrical troubleshooting, guys should be checking their line voltage, right? They should be checking their wire connections. Are they intact? They should be checking the amp draw. Is it correct? They should be checking the voltage. They should be checking all the operating and safety controls. I see that a lot out there. Guys aren't checking the safety controls. I don't have enough time to check all these different types of operating and safety controls. It's very important to check those because those controls are protecting that system, right? Are the windings open, shorted, or grounded? Understand that. From there, it's the mechanical troubleshooting. Are the heat exchanger coils clean? Is the airflow correct and is it moving properly? Is the refrigerant charge correct? Is the subcooling or superheat within design of that manufacturer's equipment? Are there restrictions in the refrigerant flow? Is the system components even sized to match what the system is? As well as check the compressor operating efficiency. And this one here is so important, Brian. We do have an app, and I've seen you do a talk about it, or at least send some posts through your social media, but Copeland mobile app. When I was a mechanic, I went out to the field and I've done tons of maintenances where I took all this information. What do I do with this information, right? Within this Copeland mobile app that we have launched, there's actually some operation efficiency features in it to tell if the compressor is running properly or if you have to start troubleshooting this compressor. So it's in this app, you will put in whatever that compressor, either scan the model number or put the model number in. Then you will go to the diagnostics tab. You will put your suction, you will put your discharge, and you will put your amps in. You will press calculate, and it will calculate to tell you if that compressor is running in normal operating conditions. Every one of our compressors that we make, the tens of thousands of compressors that we make, is in this app. And what it will do, it will help the mechanic know that compressor is running properly or not. And from there, there's a troubleshooting guide for them. If it's high current, it will go step by step for these mechanics to try to figure out what is causing the issues in that compressor. So I stress highly for the listeners out there, download this app. It's a free app, and it will definitely help you troubleshoot compressors.
I'm a big fan of that app, and it's something that I didn't know about up until fairly recently. And it really makes life a lot easier because so often, like when you're trying to figure out if a compressor is working right or not, especially on the compression side, you're kind of guessing because there's so much, it's in a closed loop system, right? So you're looking at, oh, well, my compression ratio seems a little off. Well, that could be the compressor's problem, or it might not be the compressor's problem. It might be something else in the system, charge level or expansion valve operation or issues with the lines. But with this app, you plug all this information and it tells you right away what it should be, and it makes your life a lot easier. There's a lot of additional electrical diagnosis you can do with a compressor, a lot of additional things that can go wrong. But knowing the system you're working on, knowing the application, reading some of those bulletins, reading the engineering guidelines and installation best practices for a piece of equipment, having a good, solid go-to checklist that you use for different practices, whether it's replacing a compressor, whether it's commissioning a piece of equipment in the first place, depending on the type of equipment that it is. Obviously, that will vary. But having those in place are really going to help. And I would encourage those of you out there who are maybe senior technicians, maybe managers, be proactive in writing up these checklists and helping the new technicians have a process to follow. Because as you know, more and more, you have young technicians out there in the field, maybe a little bit inexperienced, maybe don't have fully the training that we would like them to have. It's sort of the nature of the industry right now, is there's just such a shortage. And so a good solid checklist, a good solid process will really help. And a lot of these Emerson resources, they're going to be linked in the show notes. They're going to be, if you go to the website, hvacrschool.com, we're going to have a post there with links to all of those as well. If you click on the podcast tab, those will be a really great starting point. But help create these things for your company, because I think you're going to do a great service for your customers, and then also helping that next generation of technicians who are going out there by getting some of this down on paper and making sure that best practices are being followed.
You're exactly right. We as an industry, we need to help the younger guys, because I see a lot of less interest in our trade across the board. And this is one of the funnest trades to be in. Every day I'm excited to learn more about refrigeration and HVAC. What we need to do is make it sexy for them, and we can do that. And I really appreciate everything that you're doing out there for the younger guys and getting this information out there to the younger techs and experienced techs, because I think it's very important. There's so much information out there. It's hard to find it all the time. Not because it's not there, it's just there's so much information that you're looking for. So I really appreciate what you do, and keep up the great work.
All right. Thank you, Trevor. Everybody seek out Emerson. Look at what they've got. They've got a lot of really great training information, and hopefully you have a great summer up there and have a nice break from the great cold white north that I'm sure you're finally breaking out of. So thank you so much, Trevor.
Thank you, Brian.
Hey, thanks for listening. Thanks for being a loyal listener to the HVAC School podcast. It's pretty cool how far this thing has gone and how many of you are listening now. But I appreciate every one of you individually for sharing it with your friends and maybe sharing your favorite episode. I'm always interested to know what your favorite episodes are, the ones you like, or maybe the ones you don't like, maybe the ones you felt like were a waste of your time. You can always email me, brian@hvacrschool.com. I always appreciate that. A couple things I want to let you know about. First off, we're a member of the Blue Collar Roots Network. You probably already knew that. You can find all the other shows by going to bluecollarroots.com. Actually, a recent episode of the Service Business Mastery podcast was very interesting. Tersh did a really kind of a freaky, when I say freaky, just like freaky to do on a podcast, talking about his considering letting an employee go and kind of what went into that, which was interesting. So you might want to listen to that, especially that last one. And then a couple other things I want to mention. I'm doing some things with Danfoss again. Danfoss has a refrigeration controller, the ERC 213 kit. I was interested in this product. I reached out to them and said, hey, would you be interested in doing something with this? And they said, sure enough. We're using these in a couple different applications where the old electromechanical controllers, the old style controllers, aren't doing the job. And the nice thing about the Danfoss controller is that it has these settings so that it's really easy to use for kind of some default settings you can go in. You can set it up for a refrigerator, a cooler. You can set it up for a freezer. You can set it up for electric defrost or hot gas defrost. All these different options you can build into it, but it has kind of some standard settings so that you don't have to go in and set every single parameter. Just a really nice universal digital control for coolers and freezers, and that's the Danfoss ERC 213, so check that out. Also, I wanted to mention RightSoft. RightSoft is working with us now. I'm excited for that. I really enjoy their products, Manual J, Manual D. If you haven't looked at RightSoft, if you're using some other product, maybe because it's less expensive or whatever, I would tell you, based on all of the features that you get in RightSoft and how accurate it is, just listen to the previous episodes with Jack Rise. He'll kind of cover that. I would definitely suggest that you take a look at RightSoft. And then finally, Retrotech blower doors, duct leakage testers, their precision manometers, all really great things. If you want to get more into the building science side of things, the stuff that Bill Spohn talks about on the Building HVAC Science podcast, I would highly suggest that you take a look at Retrotech. And then finally, I don't know if you saw the recent award ceremony, but yeah, the Scarecrow actually won the occupational award. Yeah, because he's always outstanding in his field. All right, thanks for listening. We will talk to you next time on the HVAC School podcast. Oh, real quick, that last joke was submitted by my technician, Jeff Crable. So thanks, Jeff.